everyone, myself Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to solve Question Bank Module 1, that means Introduction to the Electrical Circuit. In that Part A questions, that means problem solving and critical thinking questions. Here, we have total 15 questions. In that first question, calculate the equivalent resistance and source resistance for a given network. So, in this given network, determine equivalent resistance across the source terminal. So, here determine equivalent resistance and source current. This source current means first determine R equivalent. For this, simplify this circuit into single resistance, that is R equivalent. So first to simplify that, so take the circuit. So first starts from here, source side. Here you need to determine R equivalent. First, here 5 and 4 are connected in series. Elements connected one after another. In case of series case, R equivalent equals to R1 plus R2 plus R3 till Rn if a number of resistors are connected in series. Here 5 and 6 are connected in series, means the equivalent resistance for this case 5 plus 6, that one is 11. Now here 3 and 11 are connected in parallel. 3 and 11 are connected in parallel. Means in the parallel case, two resistors are connected in parallel case. R equivalent resistance, reciprocal of equivalent resistance equals to R1, 1 by R1 plus 1 by R2. Now for this, if you simplify this, R1 into R2 divided by R1 plus R2. Here 3 into 11 divided by 3 plus 11. So 3 and 11 are connected in parallel indicates that value is 2.357. 11 into 3 divided by 11 plus 3. Now next, these two are connected in series. So these two are connected in series means 2.357 plus 2. So that value equals to 4.357. Now again, these two are connected in parallel case. Next, parallel combination. Parallel case, next 5 into 4.357 divided by 4.357 plus 4. 357 plus 4. Now this value is 2.32 only. Now again, these two are connected in series. These two are connected in series means, so this value equals to series connection. Series connection indicates, so R1 plus R2, that one equals 4 plus 2.32, that equals to 6.32 ohms. Here the calculate the equivalent resistance means that equivalent resistance equals to 6.32. Now second question in this, source resistance. Source resistance means here source resistance means this is the source voltage and this one is the equivalent resistance. Now here source resistance, this one is the voltage 30 volts and R equivalent is this one 6.32. Now you will get the answer for this. This current I equals to 4.74. This equivalent resistance is 6.32, 4.74. Now this one is the 4.74. First, to find out the current source current, first determine the equivalent resistance. So equivalent resistance here determined by series parallel formulas. Next, second question, use the network reduction technique and calculate the current response in each element. Here, this is the circuit. So in this circuit, we can determine the current flowing through the each resistor, current response in the each resistor using mesh analysis we can determine. But here use network reduction technique. Here simply you can apply 3 KVL equations in each mesh, and you can determine the mesh currents. After that, current flowing through the each resistor in terms of mesh currents you can determine. But here use network reduction techniques only you determine. Network reduction techniques means series parallel combination. After that, current division and voltage division rules. So first simplify this. These two are connected in parallel. So 3 and 6 are connected in parallel. So 3 into 6 divided by 3 plus 6, 9. 18 by 9, that equals to 2. And next these two are connected in series. And these two are connected in series means 5 plus 2, that is 9. Sorry, 7. Next, this is 7, and these two are connected in 8 and 7 are connected in parallel, and these two are connected in series, and these two are connected in parallel. Now in the parallel case, 8 into 7 divided by 8 plus 7, that value is 3.73. 3.73. Now again these two are connected in series. Now in that case, so 6 plus 3.73, that is 9.73. Now here first calculate the current response in each element, not a source current. So now here first determine source current. This current, source current equals to 25 by 9.73, that value equals to 2. This source current equals to 2.56. This current equals to 2.56, and this current equals to 2.56. This is I, and this current equals to 2.56. This is the I. Current flow through the 6 ohms resistor. So 6 ohms resistor current is completed. Now we need current flow into the 8 ohms resistor and 5 ohms resistor. Next 3 ohms resistor and 6 ohms resistor. Here first we can use current division formula here in this. So 8 and total current is 2.56, and these two are parallel branches. So for that case, so here if two resistors are connected in parallel and total current is given, for that particular case, that formula I am writing here. This is the R1 and this one is the R2, and this is the total current IT, total current. If you know these 3 parameters, R1, R2, parallel resistors and total resistance, you can determine the individual resistor current IR1 and IR2. Here IR1 equals to opposite branch resistance R2 divided by total branch resistance R1 into total current IT, total current. Similarly, next to IR2 equals to R1 opposite branch resistance divided by R1 plus R2 into IT, total current. Now here in this case, in this total current is 2.56, and this is current flowing through the 8 ohms resistor. This 8 ohms resistor is opposite branch resistance is 7 and total resistance 8 plus 7. So now this is the IT and this is opposite branch and total resistance 8 plus 7. Now current flowing through the 8 ohms resistor is the 1.19 amperes. Next, current flowing through the 7 ohms resistor. So same total resistance, total current 2.56, opposite branch current flowing through this 7 ohms resistor current, opposite branch is 8 ohms, 8 plus 7. Now 1.36 this amperes. Now we have this 7 ohms, 1.36 ampere, and this one is the 1.19 ampere. Now we need 2 ohms resistor branch. So here this total branch current is 1.36. So that is divided. So now here next point, here we need 3 ohms and 6 ohms resistor. So 1.36. So this current is 1.36. Here the here current is divided here. these two currents, this is and this one. So 1.36 and opposite 3 for this, this is 6 ohms current, 6 ohms resistor current equals to 1.36 and 3 plus 6 into 3, that equals to 0.45. Next, this current flowing through the 3 ohms resistor equals to same 1.36 opposite branch resistance 6 and 3 plus 6, that equals to 0.9. So this is normal network reduction technique. From the mesh analysis, nodal analysis also we can determine this current flowing through, current response in each resistor, current flowing through the each resistor. Next, third problem, calculate the power across each element. Power across each element in this given circuit. So here total how many elements are connected in series? So 5 kilo ohms, 10 kilo ohms and 7.5 kilo ohms, and that total circuit is connected across 45 volts. Now here we can determine easily the current flowing through the circuit. So here all are connected in series means only same current flows to the each element. Now in that case, first determine 45 volts. Solution for this. So 45 ohms, same current, only I1 current is flows, same current. So that current equals to 45 volts, this one. And this 5 kilo ohms, 10 kilo ohms and 5 kilo ohms, 10 kilo ohms and 7.5 volts. Now current value equals to 2 into 10 power minus 3, that equals to 2 milliamperes. This is in amperes. Now we need the power. So we need the power across each element. So power across this and power across this, power across and this, not voltages. V is equal to IR and I equals V by. Now power equals to voltage into I, and power equals to this V is equal to IR means R into I, and that equals to I square R. You can write V square by R also now. So you can use here. Now I'm using this I square R formula now. So first one, here we know the R value and current value. So same current flows to the each element. That I is 2 into 10 power minus 3. So I square R formula. So here R value is 5 kilo ohms. So now here 5 kilo ohms and this current is 2 into 10 power minus 3 whole square, that equals to 0.2 watts. Now here second power across 5 ohms is 0.02 watts, and power across 10 ohms equals to 10 kilo ohms, and this one is the 2 into 2 milliamps, 2 into 10 power minus 3 square I square R. So that is 0.04 watts. Next, power across 7.5, that equals to 2 into 10 power minus 3, and this I square R. So that is 0.03. So now power across each resistor, each element is, this one is 0.02, 0.04 and 0.03. Now fourth question, calculate the equivalent inductance. This is important. Now here 40, 20, 40, 20, 30, 50 and 100 millihenries. Inductance per units are in henries. Now here across this source terminal, determine equivalent resistors. Now here in this, these two are connected in series. In this, these two are connected in series. So 100 plus 40. In inductor case, 2 inductors are connected in series. So L equivalent equals to L1 plus L2 plus L3 till Ln. If a number of inductors are connected in series, so that in that case L equivalent equals to equivalent inductance equals to L1 plus L2 plus Ln. So now here we have only 2 inductors, 48 100 millihenries, 40 millihenry and 100 millihenries are connected in series. For that case, L equivalent equals to 40 plus 100 millihenries. Sorry. Now 140 millihenries. Now 140 and 50 are connected in parallel. So this is 140. So come this one and these two are connected in parallel. 140 and so now second case, if 2 inductors are connected in parallel. So 1 by L equivalent equals to 1 by L1 plus 1 by L2. 1 by L2 till 1 by L if a number of inductors are connected in series. So for that case, reciprocal of equivalent inductance equals to sum of the reciprocal of individual inductances. So 1 by L equivalent equals to 1 by L1 plus 1 by L2 plus 1 by L3 till 1 by LL. Here we have only two inductors are connected in parallel. For that case, L 1 by 50. So 1 by L equivalent equals to 1 by L1 plus 1 by L2, that equals L equivalent equals to L1 into L2 divided by L1 plus L2. Now here two inductance 50 and 140 divided by 50 plus 140. So for that case, the value is 36.8 millihenries. Now here these two are connected in series. So 36.8 plus next 20, that equals to 56.8. Now this 56.8 and 30 are connected in parallel. Now in that case, so that L equivalent equals to 30 into 56.8 divided by 30 plus 56.8. Now the value is for this one, so 19.6. Now these two are connected in again series combination. 19.6 plus 40, that equals to 59.6. This one, and these two are connected in parallel. So for that case, 14.6. Now equivalent inductance between the source terminal, so 14.6 millihenries. All are rated in millihenries. So final value also 14.6 millihenries. Now fifth problem. Apply the mesh analysis and calculate the current above through each element, current flowing to the each resistor. This is a given circuit. In this given circuit, current flowing to the each resistor, current flowing to the 4 ohms resistor, 2 ohms resistor, 5 ohms resistor, this 5 ohms resistor, 3 ohms resistor, and 6 ohms resistor. Each resistor current you need to determine using mesh analysis. So here for the mesh analysis, you are supposed to follow total 5 steps. So that 5 steps are: first determine the current flow, determine possible number of meshes. Identify the possible number of meshes. How many meshes here? 1, 2, and 3 meshes. So this is mesh 1, mesh 2, and mesh 3. And assume the mesh currents. In the step 2, assume the mesh currents. So this is the I1, this is the I2, and this is the I3 in clockwise direction only. In clockwise direction only. Assume the mesh currents in clockwise direction. After that, apply KVL in each mesh using Ohm's law. So here, using this I1, I2, and I3, apply KVL, Kirchhoff voltage law, in the mesh 1, mesh 2, and mesh 3. First mesh 1, write the mesh equation, KVL equation first. So 20 is the rising voltage EMF, that is 20. So minus, this is plus, and these 4 and 5 are resistors. So voltage drops. There may be voltage drop. So for voltage drops, always take negative sign, and for rising voltages, voltage sources take always positive signs. Here 20 is always positive sign. Current is flowing from minus to plus. Okay, that is okay, fine. Now this is 4 into I1 in using Ohm's law. Ohm's law means here V is equal to IR. Voltage across any element is directly proportional to the current. V is directly proportional to the current, and V is equal to IR. R is a proportionality constant. And this V equals to 4 into I1. In terms of mesh currents only, you write the KVL equations using KVL. 20 using Ohm's law, 20 minus 4 into I1 and 5. For this case, the current voltage across this 5 ohms. What is KVL? Algebraic sum of total voltages in a loop equals to 0. Algebraic sum of total. So here 20 ohms and 4 ohms. This 20 ohms and this 4 20 volts plus this 4 ohms voltage plus next this 5 volts voltage, 5 ohms voltage. The summation must be equal to 0. For that case, 20 is as it is, that is voltage, and this 4 into I1, that is voltage, and this 5 into I1 minus. Here we have two current response in terms of mesh currents for I1, I2, I1 minus I2. If you apply, this is the current I1 and this is the current I2. This current equals to I1 minus I2 from the top to bottom. And from the bottom to top means, so this is the current I2 and this is the current living current. This is the I1 current and this is the upward. So this is the from bottom to top is I2 minus I1. So just consider from the top to bottom only. Now in this case, don't consider this one. Okay, if you take it, you may get confused. So I1 minus I2. Just keep it in mind. So downwards current. So 5 into I1 minus I2. This is the first equation. If you simplify this one, so 9 into 4 plus 5, that is 9. And this is minus 5 I2. Next, there is no third mesh current response. This one, and this is the 20 volts. This is equation number 1. And second mesh equation, if you apply KVL in this loop, this current is the I2 minus I3. And now here they are considering I2 minus I1. So this one. So 5 into I2 minus I1 plus this 5 into I2 minus I1 plus 2. They take this current and this current is opposite direction. So take this I2 minus I1 only. So that direction should be in the direction of mesh current only. Now here 5 into I2 minus I1, 2 into I2, this one, this voltage, and this voltage is 3 into I2 minus I3. Now in this case, so minus 5 I1 plus 10 I2 and 3. So now here minus 5, this one, minus 5 I1 and minus 3 I3, this one, and summation of the 5 plus 3 plus 2, 5 plus 2 plus 3, that is 10. And there is no voltage source in this mesh. So that value is, that is equal side value is 0. That is equation number 2. Now third mesh, in this also there is no voltage source, no current source. Now you can apply KVL in this loop. Now 3 into I3 minus I2, this one, and 5 into I3 and this 6 into I3. Now here in this case, if you simplify this same, so there is no I1 effect for this mesh 3 and 0 I3 and minus 3 I3 I2 plus 3 plus 5 plus 6 that equals to 8 plus 6 is the 14. There is no voltage source, that value is 0. Now we have equation number 1, 2 and 3. Now we can solve these three equations. We will get I1, I2 and I3. Now first write in the matrix format. So how you will write the in matrix format? So solve this KVL equation and find out the mesh currents. So first, so 9 this one and 5 this one and this 0 this one, and next 5 this one, 10, 3, 0, next minus 3 and 14, next 20 and 0 and 0. Now so this is matrix form I1, I2, I2, and this matrix A and this I matrix and this voltage matrix. This is resistance matrix. Now if you multiply this with this I matrix, then you will get same three equations 1, 2, 3, 1, 2, 3. Now solve these three equations using Cramer's method or any other method, inverse matrix method. So if you solve that, you will get I1, I2 and I3. I1 equals to 3.16 and I2 equals to 1.69 and I3 equals to 0.36. So now these are the mesh currents only. Here in the question, current above through each element. So this is important. So these are not mesh current. These are not each element currents, branch currents, resistor currents. These are only mesh currents only. Mesh currents only, not mesh currents. Mesh currents and mesh currents are not equals to branch currents. I1, I2 and I3, we are assigned the currents to each mesh, I1, I2 and I3. These are the mesh currents only, not branch currents. Now here, so from the mesh currents and determine the current flow into the each resistor, branch currents. So these are mesh currents and branch currents are not same, that are different. So here, so these are the mesh currents I1, I2 and I3. Now current flowing through the 4 ohms means this is the I1, so I1 current, and current flowing through the this I1 means this one I1 4 ohms, and current flowing through the 5 ohms resistor means, so this 5 ohms means I1 minus I2, so this one. So this one I1 is 3.16 and I2 is 1.69. So if you take subtraction, I1 minus I2 and 1.47. Now here current flowing through this 2 ohms resistor is this one. This is 2, not 5. There is a wrong. And this one is the I2, current flowing through the 2 ohms resistor, and this one is current flowing through the 3 ohms resistor and current flowing through the 6 ohms resistor. So I2 is this one and I3 is this one, I3 is this one. Same current flows to the each element in the 5 and 6 because they are connected in series. So now here current flowing through the 3 ohms resistor is the I2 minus I3, that equals to 1.33 amperes. Now, so now we determine current flowing through the each resistor. Now, node voltages. Calculate the node voltages and power absorbed by 7 ohms resistor. Now here this is the resistor. Node voltages means from the nodal analysis we can determine the voltage. We can determine the current flowing through the each resistor, and we can determine the voltage across the each resistor, and we can determine the power. If you know the resistor, already we have the resistors, and if you know the current value and if you know the voltage values, we can determine the power value. Simply we can determine. So here the best method to find out the current flowing through the each resistor is the mesh analysis. Already we discussed in the mesh analysis and nodal analysis concept, and the best method to find out the voltage across the each resistor is the nodal analysis. Here first determine the voltages and node voltages, then determine the power. P equals to V into I. So Vp equals V into I, and I square R or V square by R. So from this. So now what are the steps total? Same steps of mesh analysis, there are 5 steps same. So step 1, determine. First one is the identify number of the possible number of the junctions here. In case of mesh analysis, identify the possible number of meshes. Here junction means, what is meant by junction? Junction is a 3 or more elements connected to one point. Here resistor 6 and 7, 8 and 10 are connected to this point. So this is the junction 1. Now here second junction is this. These 3 elements 6, 7 and 9 are connected to this one. Now see here. Now this is junction 2. And these 40 volts and this one are connected to this. So this is junction 3. So now we have 3 junctions. And so assign the second step is assign the junction voltages V1. First junction voltage is V1, and second junction voltage is the V2, and third junction voltage is the V3. So now here step 1, determine possible number of junctions. This is junction 1, junction 2 and junction 3. 1, 2 and 3. And step 2 is assume the junction voltages V1, V2 and V3. So here out of these 3 voltages, select one junction as a reference junction. That reference junction voltage equals to 0. That is ground voltage. Now better to take bottom one. So if you take bottom one, the calculations are very easy. Now here V3 I am selecting as a reference voltage. That voltage equals to 0. Now apply KCL at each junction. You no need to apply at reference junction. Just remaining junctions you can apply KCL. So KCL, what is meant by KCL? Algebraic sum of currents at a node equals to 0, or sum of entering currents equals to sum of leaving currents at a node. So now if you apply KCL at this node, so at node 1, so now here, so how many elements? So what do you mean by current? Current equals to voltage potential difference divided by So voltage equals to potential difference divided by resistance. Sorry, this is the current. Current means voltage. Voltage means potential difference. V by R. Voltage means potential difference. So now here, what are the potential difference? Here first, how many elements connected to junction 1? So 10 ohms, 7 ohms, 6 ohms and 7. Now here, this is the 8 ohms current and this one is a 10 ohms and this one is a 7 ohms and this one is a 6 ohms. 6 ohms current plus and 10 ohms current plus 7 ohms current plus and 6 ohms current must be 0 according to the KCL. Sum of currents at a node equals to 0. All currents at junction 1 must be 0. That is Kirchhoff current law. This 8 ohms resistor current, 10 ohms resistor current, 7 ohms resistor current and this one. How you will calculate the current? And this current equals to potential difference divided by resistance. Resistance values already we know is 7, 10, 7, 8, 10, 7, 6. Now here the potential is V1 and this potential is 40. And this voltage across, potential difference between potential difference across this 10 ohms is V1 minus 40. And this one V1 minus V3. And for this 8 ohms. And V1 minus V3 is voltage across this one, and voltage across this 10 ohms is V1 minus 40, and voltage across this 7 ohms is V1 minus V2 and this one, and voltage across this 6 ohms also same, because these two are connected in parallel. In the parallel case, same voltage developed across each element, that voltage is supply voltage. So here V1 minus V2 for 7 ohms resistor voltage and 6 ohms resistor voltage. Now this is the equation number 1. If you simplify this one, so here 0.053 V1 minus 0.31 V2 is equal to 4. Now this is the equation number 1. Now same way here at this junction 2 apply KCL. Now V2 minus V1 by 7 and V2 minus V1 by 6, this same voltage, this voltage and this voltage is same, and V2 minus V3 by 9. Now here there is an assumption, the V3 equals to 0 and this V3 equals to 0. There is here also V3 equals 0. Reference junction voltage must be 0. Now here minus 0.31 V1 and 0.42 V2 is equal to 0. Equation number 2. Now if you solve this, these are the junction node voltages. From the node voltages we can determine current flow into the each resistor. So solve the KVL equations 1 and 2 and you will get the junction voltages, node voltages. V1, V2, not V2. V3 value is 0 already. So V1, V2 and V3. So V1 equals to, so now this is 0. If you write in the matrix format, so now this is 0.53, this one is this one 0.3 and this one is 0.31 and this one is a 0.41, V1 and V2 and 4 and 0. Now V1 value and V2 value equals to 13.2 and 9.8. Now here in this, these are the node voltages. Node voltages we determine. And power absorbed by 7 ohms. Power absorbed by 7 ohms means V1 minus V2. V1 minus V2. This whole square by 7. That value. From the junction voltages you can determine. This is the current. So I square into R you can determine R. This V1 minus V2 whole square by 7. If you do that you will get the voltage across the power across the 7 ohms resistor. Now 7th question, calculate the voltage to be applied across AB in order to drive a current of 5 amps in the circuit by using star delta transformation. This is most important problem. So this is the circuit diagram. So in this circuit, simplify this, just between these two AB terminals, determine R equivalent. Then if you want to know the voltage, then that this current 5 amps and multiply with this current with equivalent resistance, then you will get the voltage across the AB terminals. Now here this one, these two are 2, 3 and 5, and this 10 and 5 are connected in delta connection. What do you mean by delta connection? So if three elements are said to be in three resistors are said to be in delta connection. So first resistor, first element, second end is first 1, 2, 1, 2 and 1, 2, 1, 2, 1, 2 and 1, 2. So first element second end is connected to second element first end, and second element second end is connected to third element first end, and third element second end is connected to first element first end. So that is known as delta connection. So the first, so remove the delta connection. So from the delta connection to the first convert into the star conversion. Then you will get, you may idea. We cannot say all which resistors are connected in series and which resistors. For that case, you go for the star delta derivation. Here these three are connected in delta, and this one is, these three are connected in delta. Now here in this case, this is the delta connection and convert it to the star. So now here, so now this resistor equals to 3 into 5 divided by 3 plus 5 plus 2. Sorry, not 5, 2. This adjacent resistors multiplication divided by total 3 resistor summation. So 2 into 5 divided by 2 plus 5 plus 3, and this resistor equals to this resistance value equals to next 3 into 5 divided by 3 plus 5 plus 2, and this resistor equals to 3 into 2 divided by 3 plus 5 plus 2. Same way here 5 into 10 divided by 5 plus 10 plus 5, and this one is 5 into 10 by 5 plus 10 plus 10, not 5 here, 10, and 10 into 10 divided by 10 plus 10 plus 5. Now the simplified one, this is 2 and this is 2 and this one is the 4, and here 0.6 and this is 0.6 and this one is the 1, sorry not 1, 1.5, and this one is the 1, and here is the 2 and this one is the 4. Now these three are connected in series. In case of here 3 resistors are connected in series. In case of series connection, so some equivalent resistance equals to sum of the individual resistances. 3 plus 2 plus this one, 3 plus 2 plus and 1, and this one 1.5 plus 2 plus 4, this one, this equivalent and this one. So now again these two are connected in parallel connection. So see that, yes, so this one 3 plus this one is a 6 and this one is a 7, and these two are connected in the parallel. So in the parallel case, so 6 into 7.5 divided by 7.5 plus 6. So that equivalent resistance, that case, so that value is 3.33. Now these three are connected in parallel. So now these three are connected in, sorry, not parallel, series connection, 0.6 plus 3.33, and this one is 2. Now the final value is 5.33. So now this is only current equivalent resistance or equivalent. So in the question, the question asking voltage to be applied to this one equals to, this current equals to 5 amps. So what about voltage equals 5 into V is equal to IR. This R equivalent into this one equals to this one, 5 into 5.93, that equals to 29.65 voltage to be applied across the AB in order to drive this 5 amps current in the circuit by using star to delta conversion. Next, 8th question. Determine current flow into the 800 ohms in the network. So this is the circuit. You can use the best method to find out the current flow into the each resistor is the mesh analysis. That mesh analysis concept you can use in for this circuit to determine the current flow into the each resistor. Here possible number of meshes. Here 3 number of meshes, mesh 1 and mesh 2 and mesh 3, or you can assign 1, 2 and 3. So and apply, assume the mesh currents. So see the steps, determine possible number of meshes here. So mesh 1, mesh 2 and mesh 3. One total number of meshes here 3. Now here assign the mesh currents I1 and I2. Sorry, not this is I1. This is the I1. This is the I2 and this is the I3. And in clockwise direction only. That is important. If you take one is in I1 is in clockwise direction, I2 is in anti-clockwise direction, readings may to get wrong, and apply KVL in this mesh, each mesh. So here 4 is the rising voltage and 80 into I1 minus I2 and 750 into how many number of elements connected to mesh 1 here 4, 80 and 750. So now this is the 4 is the rising voltage and these are the drops, voltage drops minus 80, I1 minus 80. I1 this 80 is associated with I1 and I2 and the 750 is associated with I1 and I3. So this is the equation number 1. The simplified equation is 830 I1 minus 8 I2 minus 750 I3 that equals to 4. Next, second equation, associated elements 80, 200 and 80, 200 and 800. So 80 into I2 minus I1 and 200 into I2 and next 80, 800 into I2 minus I3. 800 is associated with I2 and I3. Now the simplified equation is minus 80 I1, 1081 and 8080 I2 and next 800 I3 that equals to 0. That is equation number 2. Next, third equation for in the apply KVL in mesh 3. Now here 750 I3 minus I1 and 800 I2 minus I2 I3 minus I2. Next 2000 I2 2 kilo ohms. Now if you simplify this one, minus 750 this one I1 and minus 800 I2, and if you add these 3 resistors and that one is 3550 I3 that equals to 0. That is equation number 1. Now these are in equation format, convert it to the matrix format and solve that matrix using Cramer's method. So solve the KVL equations and determine the mesh currents I1. So this is the 830 and this one and this one and this is the 750 and this is the 80 and this is the 1080 and this one is this one 800 and next 750 800 minus 800 and this one is a 3550. Now here voltage is 400. Now solve this using Cramer's method. For this curve minus 0.00660 and I2 is 0.00 and 183 this one and I3 is 0.00 and 181.01. These are the mesh currents. From the mesh currents you can determine the, now we got the I2 and I3. From the I2 and I3 we can determine this 800 ohms resistor. This 800 ohms resistor current I1 minus I3 is the from the top to bottom and from the bottom to top is the I3 minus I2. From if you consider this one I1 minus I2 and if you consider upwards and I2 I3 minus I2. I1 minus I2 minus I3 and this is I3 minus I2. Downwards is I1 minus I2, that from means that top to bottom, and upwards indicates I3 minus I2. So keep it in mind. So now this one, that value is 0.0002. So that is 20 micro amperes, almost 0. Next, ninth question. A sine wave has frequency 50 kHz. How many cycles does it completed in 20 milliseconds? So first determine the time period. So time period equals, what is the formula? 1 by f. So reciprocal of frequency is known as time period. So now here frequency equals to this one 20 kilohertz. Now that time period equals to 0. So how many cycles does it completed in 20 means that number of cycles completed in this. So the time and divided by time period, that equals to 1000 number of cycles completed in 20 milliseconds. Now here a sine wave has peak value 25 volts and state the following values. Determine the following RMS value and peak to peak value and average value. So here for this sine wave, this is the sine wave. For this sine wave, so the related formulas that I am writing, the given data here 25 volts V maximum, and so V RMS equals to this formula V maximum by root 2 and V phase to phase value. So this is a V maximum and this one is the minus V maximum. So that is 2 V maximum, this one, peak to peak value, this one, and average value equals 2 Vm by pi. So these are the three formulas. We know the maximum value, then we can substitute in this. So 25 by root 2 and this one, 2 into 25, this one, and next one is the 2 into 25 by pi. So now final values, so 17.6, 50 and 15.9, all are in volts. So total 10 questions. Next, 11th question. The time period of sine wave is 20 milliseconds and state the frequency. Same, reciprocal of frequency is equals to time period, or reciprocal of time period equals to frequency, inversely proportional. So 1 by 20. So now here this one, 20 milliseconds. So that equals to 1 by 20 into 10 power minus 3. So now that is 1000 by 20, that equals to 50 Hz. This 12th question. The frequency of sine wave is 30 Hz and what is the time period? Same, reciprocal of frequency equals to time period. This one, frequency equals to 1 by 30. That equals to 1 by 30 and that value equals to 33.33 milliseconds. So just simple formula. T is always inversely reciprocal of frequency is known as time period, or time period this one, second inverse, frequency equals to 1 by reciprocal of time period. Next, a wire is carrying a direct current of 20 ampere. This is DC current, and sinusoidal alternating current of peak value is 20 amps, and mention the RMS value of the resultant current in the wire. So here mention, so resultant RMS value, the given here DC current is 20 amps and AC current is that is maximum value is 20 amps. Now here RMS value equals to this DC current square, and this is the I maximum, this one 20, and 20 and 20, if you simplify this one, 20 square plus 20 by root 2 and whole square. Now this value is 26.13. This RMS value is the 26.13. This one. Next, 14th one. A sinusoidal voltage applied to capacitor 0.01 microfarads and the frequency of sine wave is 2 kHz, and determine the capacitive reactance. What about capacitive reactance? 1 by 2 pi Fc, and we know the C value and we know the frequency value, and then we can determine easily the capacitive reactance. So see the given data, C equals to 0.01 microfarad and F equals to 2 into 10 power 3, not minus 3, is Hz. Now what is the formula here? 1 by 2 pi Fc. Substitute in this. So 2 into this is the F into this one is the C, 2 pi Fc. Now the final value is 7960. This is in reactance, capacitive reactance. Now next 15th question regarding inductive reactance. A sinusoidal voltage applied to a inductor 2 millihenries. This is now the frequency of sine wave is 3 kHz. Same, this is the L and this one is the F, and determine the inductive reactance. Now the given data, L equals to 2 into 10 power minus 3 and F equals to 3 into 10 power 3. Now inductive reactance equals to 2 pi FL. This one. So substituting this is the F and this one is the L. 37.66. Total 15 questions are important for CIE examination point of view. If you still have any doubts in these 15 problems, you can comment in the comment section below. I will answer to your doubts. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.